Measurement System Analysis, Section Overview and Objectives. By the end of this session, you will learn what is precision and accuracy, what is bias, linearity, and stability, what is gauge repeatability and reproducibility, what is variable and attribute MSA. Measurement System Analysis, Precision and Accuracy. There are two critical characteristics to examine in a gauge system. Accuracy. Accuracy is an unbiased true value and is normally reported as the difference between the average of a number of measurements and the true value. Checking a micrometer with a gauge block is an example of an accuracy check. Precision. In gauge terminology, repeatability is often substituted for precision. Repeatability is the ability to repeat the same measurement by the same operator at or near the same time. As you can see in the diagram, in the first example on the left, all the dots are precise but not accurate. The diagram in the center, the dots are accurate, that is, within the circle, but not precise. In the diagram on the extreme right, the dots are accurate and precise. The calibration of measuring instruments is necessary to maintain accuracy, but does not necessarily increase precision. In order to improve the accuracy and precision of a measurement process, it must have a defined test method and must be statistically stable. Measurement methods: bias, linearity, and stability. Bias. Bias is the difference between the output of the measurement system and the true value. It is often referred to as accuracy. Bias has a direct impact on the process output and can change the inferences of data analysis. Linearity. Measurement system linearity is found by obtaining reference part measurement values throughout the operating range of the instrument and plotting the bias against the reference values. Linearity will cause problems at the extreme values of the operating range. Stability. Variation in measurement when the same person measures the same unit using the same measuring gauge or tool over an extended period of time. If stability is not consistent, it may require additional costs of regular maintenance of the tools or instruments. Repeatability and reproducibility. Assuming that gauge accuracy and sensitivity are adequate, it is often desirable to determine the variance components of a gauge measuring system: repeatability, reproducibility, and process. There are three widely used methods to quantify measurement error: the range method, the average in range method, and the ANOVA method. A brief description of each follows. Range method. Reproducibility is the variability introduced into the measurement system by the bias differences of different operators. The range method does not quantify repeatability and reproducibility separately. The range method is a simple way to quantify the combined repeatability and reproducibility of a measurement system. To separate repeatability and reproducibility, the average and range method or the analysis of variance method must be used. Average and range method. The average and range method computes the total measurement system variability and allows the total measurement system variability to be separated into repeatability, reproducibility, and part variation. Gauge repeatability and reproducibility. Measurement system errors can be due to repeatability. Variation in measurement when a person measures the same unit repeatedly with the same measuring gauge or tool. Reproducibility. Variation in measurement when two or more persons measure the same unit using the same measuring gauge or tool. There are certain thumb rules for acceptable levels of measurement system variation. For continuous data, if the percentage tolerance is less than 8%, percentage contribution is less than 2%, and number of distinct categories is greater than 10, then the measurement system is acceptable. Likewise, we would evaluate the risks of the measurement system if the percentage tolerance is between 8% and 30%. Percentage contribution is between 2% and 7.7%, and number of distinct categories is between 4 and 10. The measurement system is unacceptable if percentage tolerance is greater than 30%, percentage contribution is greater than 7.7%, and number of distinct categories is less than 4. For discrete data, the measurement system is acceptable if accuracy is greater than 90%, repeatability is greater than 90%, and reproducibility is also greater than 90%. The measurement system is unacceptable if accuracy is less than 90%, repeatability is less than 90%, and reproducibility is also less than 90%. Measurement system in the enterprise. Enterprise performance can be measured and presented by using automatic counters, computer-generated reports, internal and external audits, supplier assessments, management reports, internal and external, a variety of feedback reports, suppliers, Number of product deviations, percentage of on-time deliveries, percentage of early deliveries, shipment costs per unit, shipment costs per time interval, percentage of compliance to specifications, current unit cost compared to historical unit cost, dollars rejected versus dollars purchased, timelines of supplier technical assistance, marketing and sales, sales growth per time period, percentage of market compared to the competition, dollar amount of sales per month, dollar amount of an average transaction, time spent by an average customer on website, effectiveness of sales events, sales dollars per marketing dollar, external customer satisfaction, a weighted comparison with competitors, perceived value as measured by customer, ranking of product or service satisfaction, evaluation of technical competency, percentage of retained customers, internal customer satisfaction, employee rating of company satisfaction, rating of job satisfaction, an indication of training effectiveness, an evaluation of advancement fairness, feedback reaction to major policies and procedures, knowledge of company goals and progress to reach them, research and development, number of development projects in progress, percentage of projects meeting budget, number of projects behind schedule, development expenses versus sales income, reliability of design change requests, manufacturing, key machine and process capabilities, machine downtime percentages, average cycle time for key product lines, measurement of housekeeping control, adequacy of operator training, engineering, evaluation of product performance, number of corrective action requests, percentage of closed corrective action requests, an assessment of measurement control, availability of internal technical assistance,